Today we are going to look at relationships of x and y values, and we are going to determine which of those relationships are linear functions. So, steps to determine whether a relationship between the x and y values are linear. The nice thing about the notes today is that there are step-by-step instructions for you. And I am going to color code these step-by-step instructions. So, step 1, I'm going to complete in green. Step 1. In this table of values, we need to find the consecutive differences of the x's. And I'm going to go ahead and use this terminology. Write in triangle x. Triangle x does not mean triangle x. That triangle is a Greek letter, delta, and it means the change in x. Delta x means the change in x. So, on this table for number 1, right above the x line, I am going to write delta x, the change in x. From 3 to 5, what is the change from 3 to 5? We're adding 2. That's a positive 2. From 5 to 7, what is the change? From 7 to 9, and from 9 to 11. Sometimes they are the same, sometimes they are not. Step 2, I'm going to do in blue. Find the consecutive differences in the y values. This would be delta y. So underneath the table, I'm going to write delta y, and we're going to find the differences in the y values. So from 11 to 16, what's the difference? And from 16 to 21, 21 to 26, it's plus 5. Again, sometimes they're the same, sometimes they are not. Step 3, I am going to do in black. Step 3 says divide each number in step 2 by each number in step 1. That means we need to do delta y divided by delta x. So I'm going to write under here delta y divided by delta x for each step. So the 5 divided by the 2, 5 divided by the 2. And this seems silly because we can see that they're all the same. They won't always all be the same. You just want to make sure that that ratio is the same. If that number from step 3, the delta y over delta x, if that number is the same, then the table of values is a linear function. And the nice thing about doing delta y divided by delta x, you just found the slope. So these numbers being the same tells us that this is a linear function. It also tells us that the slope of this linear function is 5/2. So now for step 5, if that table represents a linear function, pick one of the ordered pairs and write the equation in slope-intercept form. So, which 3 and 11 because it's the smallest numbers. So, write it in point slope form. Y minus 11 equals 5/2 times x minus 3. Okay, we will distribute our slope. And 5/2 times negative 3, because it's 5/2, that's going to be a decimal of 0.5. We can write the decimal 0.5. We don't have to keep this in terms of fractions. Write your slope as a fraction, but your y-intercept can definitely be a decimal here. What is 5/2 times negative 3? That's negative 15/2, which is negative 7.5. Add 11 to both sides. Plus 3.5. That looks good. Sometimes it's in decimals, sometimes it's whole numbers. It just depends. Okay, you can keep it in fractions. If you left it in fractions, it would be y equals 5 halves x plus 7 halves. Okay? Number 2, I'm again going to color code. Our first step is to determine the changes in our x values, delta x. From 2 to 7 is plus 5. 7 to 9 is plus 2. 9 to 12 is plus 3. Now, notice these numbers aren't the same. That's not necessarily a bad thing. Step 2, find delta y. So from 1 to 5, we're increasing by 4. From 5 to 11, and from 11 to 17. Now, that is a little concerning, because if the 6's are the same, then these two numbers on the top should be the same, but let's roll with it. The next step is to do delta y divided by delta x. Our first step is 4 divided by 5. The next one, 6 divided by 2, would be 3. And the next one, 6 divided by 3, would be 2. These are not the same, which means not linear. I would like you to try number 3 on your own. Find delta x, find delta y, do delta y divided by delta x, see if they're the same. If they're the same, it's linear. Write the equation. If they're not the same, it's not linear. For delta x, increasing by 1, increasing by 3, and then increasing by 2. Delta y, we're increasing by 2, and then 6, and then 4. 2 divided by 1 is 2. 6 divided by 3 is 2. 4 divided by 2 is 2. Because these numbers are the same, that indicates that this is a linear function. Okay? It also indicates that our slope is 2. So I can pick one of these points. I'm going to pick 1, 1 because I think 1s are easy to work with. Y minus 1 equals 2 times x minus 1. Distribute my slope. Add 1 to both sides. Y equals 2x minus 1. How'd you do?